So, quadratic functions. Quadratic function is a second degree polynomial function. So that means that the highest power on the independent variable, which we commonly use x, would be 2. So you'd have your leading term would be an x squared term if you're using x for your variable. So that's what second degree means, that's square. In the Cartesian plane, or the real plane, a quadratic function can be written in the form f of x equals ax squared plus bx plus c where a is not equal to 0. If a were 0, that would be a linear function, just f of x equals bx plus c. So that's why that condition is there. It wouldn't be second degree in that case. The graph of such a function is what we call a parabola, and it has a vertical axis of symmetry. Now there's ways to write out formulas for parabolas with non-vertical axes of symmetry. We'll see ones with horizontal axes of symmetry, but we won't do this section where they rotate those around any degrees or anything. It's just not so commonly done in the course. It's included in the text because some math faculty members want it. It's a favorite topic of theirs, I guess. But we're not going to cover that in this class. So we'll just have vertical axes of symmetry, and later we'll have horizontal axes of symmetry. Okay, so, but the quadratic function has a vertical axis of symmetry, always. So the standard form for the quadratic function, that is a quadratic function of this form does. Standard form for the quadratic function, f of x equals ax squared plus bx plus c, is f of x equals a, open paren, x minus h, close paren, square, plus k. So that's called the standard form for quadratic function. Now, this can get a little confusing because the standard form for a polynomial of second degree would be the first one there, ax squared plus bx plus c. The standard form for quadratic function, which is really the same thing, is the second one, and that's just because we're thinking of it as, we're thinking of graphing the parabola corresponding to the quadratic function, or solving the quadratic equation if f of x was 0, that kind of thing. So that's why we call that the standard form, because from that form we can read off what the vertex is and the axis of symmetry, which we'll get to in a second here. So the vertex there, in less than a second, so the vertex there is h comma k. And this goes alphabetical, hk, just like xy. And the axis of symmetry is the line x equals h. That's because the axis of symmetry always goes through the vertex, and the vertex, the value of x is h. And since it's a vertical line, the value for x has to be the same for all the points. So that means it's x equals h. And then, of course, implied there is that y is any real number. Whenever we're in the plane, real plane, and we say x equals h, we don't mean a point on the number line. We mean a set of points in the plane, which is x equals h and y is any real number. We just don't usually say the y is any real number part, because it's assumed as long as we know we're in a plane. Okay, so the points h plus 1 and k plus a and h minus 1, k plus a are also on the parabola. That looks a little complicated, but it's pretty easy to apply in practice, and so I'll show you with examples. So we use the vertex and these 2 points to sketch a graph of the parabola. So I have the 2 cases, one where the leading coefficient a is positive and one where it's negative. Remember, it can't be 0. And I'm just going to draw 2 different sketches of graphs. So the vertex is hk for either one. Obviously this isn't on a fixed coordinate system, or those points would be in the same place. The h plus 1, k plus a is just a point. You go one to the right of the vertex, and you go, if a is positive, you go up a. And if a is negative, you would go one to the right of the vertex, and you would go down the magnitude of a. So say a was negative 3, you would go right 1 and down 3. Right? And then you do the same thing on the other side, and you can do this because there's this axis of symmetry that goes through the vertex, and so if you reflect across that axis, you get another point. So you just go left 1 and up a if a is positive, left 1 and down the magnitude of a if a is negative. Magnitude means absolute value, right? How far it is from 0. So that's what those mysterious h minus 1 k plus a and h plus 1 k plus a things are. You just go over 1 and either up or down, up a or down the magnitude of a. Then you just sketch in your parabolas. Those are actually pretty decent parabolas for hand-drawn. Got lucky there. And the axis of symmetry is right there. It goes right through the vertex. It's vertical.